So now you know what performance testing is, or the different types of tests, or the load profiles from our previous sessions. What now? This session is about how we make sense of the performance test results through aggregation. The intention of the session is more conceptual, because understanding the story behind the data is what ultimately drives better decisions. To explain this, of course, we're going to use our famous washing machine example. So, picture this. You're walking into a store to buy a washing machine, and you're immediately faced with dozens of options. Samsung, Philips, Siemens, different brands, different sizes, different features, and price points. Each one claims to be efficient, powerful, or cost-effective. But comparing them directly isn't easy. You are overwhelmed and bombarded with information, and the way it is presented doesn't help the decision process at all. So, how would we solve this? So take, for instance, instead of relying on marketing claims, we put all these washing machines into one controlled performance test. We measure key factors like capacity, number of cycles, duration of each cycle, water and detergent use, and the overall efficiency. During that test, we collect a large amount of data over time. Every spin, every rinse, and every load. At first, what we get is a very raw, confusing graph with weird lines, peaks, and you just look at it and think, what am I looking at? I don't know what I have to do with this. It shows everything. Peaks, drops, fluctuations across the entire duration of the test. While this graph is correct, it's not particularly helpful. It tells us what happens, but not why it matters. Stakeholders looking at it may struggle to identify where the real issues lie, or which machine actually performs best. And this is where aggregation becomes essential. Instead of showing every data point, we start summarizing and grouping the data in a meaningful way. We transform raw and confusing metrics into insights, things that we can understand. For example, we might calculate average cycle times, identify peak resource usage, or highlight failure rates under certain conditions. For instance, the moment you start putting wrong items in the washing machine. We take complex and noisy data and turn it into something structured and understandable. Think of it as shifting from a detailed timeline with all fluctuations and peaks to a clear and comprehensive story. We then present this aggregated data in a new form. Cleaner graphs, focused comparisons, and short explanations that guide the audience. Instead of asking someone to interpret thousands of lines of data points and trying to understand what it says, we show them the key outcomes. Which washing machine consistently performs well? Which one struggles under heavy load? And where inefficiencies occur. Because that's information that we need. That's information that is important to us to know that, okay, take for instance, you have a apartment that produces, that gives you less water, that you want a machine that can work with that, for instance. Suddenly the decision becomes much clearer. Now in reality, our systems are far more complex than just washing machines. We're not just choosing between products, we're diagnosing performance issues. identifying bottlenecks, and ensuring systems can handle real-world demand. Take, for instance, we have always discussed the Tomorrowland tickets sales going up, or Black Friday when you want to buy a washing machine. Just imagine you're in a store and it's Black Friday and you want to buy a washing machine and you don't know which one, and all the people who can help you decide that is already with another client, and you're just standing there looking at all those washing machines and thinking, oh no, I don't know what to do, because the results are not uniform. They don't tell you what everything is and what it does, and it's also overwhelming. But the principle remains the same. Raw data alone is not enough. By aggregating performance results, we isolate the problem and we highlight the patterns. For instance, a washing machine that can handle many clothes at one time. It's a bigger compartment, whatever and not what. It provides clarity. More importantly, it enables us to take action. Once an issue is clearly identified, we can propose targeted solutions, whether that's optimizing a process, making sure that the machine can handle much more load, or seeing that, okay, we will put more people on the sale of Black Friday, that we said that there are more customers, for more customers there are more people to help them, employees to help them. We scale the infrastructure or adjust configurations. In the end, aggregation is not just about simplifying the data. It's about turning data into decisions. It allows us to move from an observation state, by just looking at something confusing and not knowing what to do with it, to understanding. And once you have understood the data, you can actually take a meaningful decision, and you can, from that decision, an improvement can come. We can actually be sure that, you know what, we're ready for Black Friday, we're ready for that sale of washing machines. Now we're going to see that all those 1,000 machines are going to be gone in the next week. And that's exactly what stakeholders are looking for. Not just numbers and weird fluctuation and peaks and weird graphs, but a clear direction forward. Because that's what we need, to know and be sure that our system will work when it's the most important.